Okay, let's start. So, good morning, good afternoon, everyone. For this session, we have with us Professor Ali Haider from Chemical Engineering Department, IIT Delhi. And as you can see the title, he will be talking about nanotechnology, climate change, renewable energy. So, it's going to be very interesting. So, Professor Ali Haider, you may start. Over to you. You are muted.
Right.
Yeah.
Thank you, Professor Rajan, for this nice opportunity. I'm going to talk on how nanotechnology and what is the role of nanotechnology in solving problems related to climate change and renewable energy. In my research interests are in catalyst materials, so I will be focusing more on how you can use sustainable catalyst materials to design new reactions or think about new technology and solve problems related to both energy and climate change. Okay? So our lab is a relatively new lab, about 7-year old, and you can visit our lab at reclab.in. Okay, and we are located at IIT Delhi, so it's very central place. So you are welcome to also visit the lab whenever you are here or you are around this area. Feel free to contact. Okay. Uh, Now, if I ask you, and this is a very valid question, if you think, if I ask you like the last century, and most of you are Generation X, so this century born, but if you imagine the last century, what was the most important discovery? What was the main thing discovered or invented in the last century? So could anyone tell me which one was the best scientific discovery or which was really, really important for human beings and that has really changed the whole world? What do you think was the last century in the 90s and earlier, 1900 to 2000? What was the main invention? Can anybody answer to me?
I think it was the transistor.
He said transistor. Yeah, transistor used to be huge, but now it's on the chip, and that has really improved the speed of all the electronic equipments. Yeah. What somebody said, internet. Internet is very important because it has really enabled the movement of this information and access to so much information to so many people. That was really important. Anybody else?
Sir, atomic nucleus.
Atomic nucleus. Yeah, so she's saying that finding this Bohr, Niels Bohr found the nuclei, and from there you came to Einstein, and then you have this nuclear energy. So that has really enabled a lot of things. Of course, some are destructive usage, but many constructive usage as well. Anyone else?
So computers.
Computers, yeah. So these are the things which you generally think about: computers, internet, nuclear energy, or you are thinking about cell phones, things in your hand. All of these things are valid. If you ask scientists, especially the Nature group of scientists, and this is one of the topmost journal in science, that's and they had this millennium, so that's like they were trying to find out what was the biggest invention of the last century, and they didn't say any of these. They didn't talk about nuclear, they didn't talk about computers or internet, nothing. They said the Haber-Bosch process of ammonia synthesis. You might be reading chemistry, and in 10 plus 2 you read about this N2 plus hydrogen going making ammonia. They said in 1920 Haber was able to visualize that it's going to be an explosion. Okay, so it's going to be an explosion of population. So population was less than 2 billion here, and Haber said that they were able to see right here that it's going to explode on the planet. Right now we are about more than 7 billion, so and it's going to be 10 billion. So they said, okay, we are going to feed this entire planet. How it's going to happen? And Haber said that I'm going to fix nitrogen. Nitrogen molecule is a very difficult bond, like triple bond of nitrogen, very difficult to activate. But they said, okay, I am going to fix nitrogen and provide bread. Okay, so that was really it is that the bread, the food will come from the air. They said that I can fix the nitrogen triple bond, and that will be your bread. You are going to eat it. This is how it is explained. Of course, they were doing science, so they were trying to fix nitrogen to make ammonia, and they were able to see that the population is going to explode, so ammonia is required to make fertilizers. Okay, so the scientists said that the best invention in the last century was actually this process, Haber-Bosch process. This is actually voted innovation of the century when you were born. Exactly at that time, the last 100 years of research, they said that it is enabling the use of fertilizers through which the whole planet is fed. So that is amazing. Okay. Now this was 1920, and we are in 2020. And Haber got the Nobel Prize. He's one of the chemical engineers, early chemical engineers who actually got the Nobel Prize for doing this process. And it was very tough, but he could discover a catalyst which can break the nitrogen triple bond, make ammonia. Okay, but that was 1920. Now you are sitting here in 2020. If I ask you what is the major challenge, can you tell me, like Haber, what is the challenge ahead in your life? Because you are also sitting 100 years later at the right time of the century. That what is the biggest challenge in life? Okay, what problem you are going to solve? So can anybody tell me what is the challenge today?
So global warming.
Global warming, that's great, because the title is also climate change. So climate change is the challenge. What else is there?
So pandemics.
Pandemic is a challenge, but pandemic is usually, we had a pandemic in 1920, that's for 3-4 years. Maybe this pandemic is for 3-4 years, then the planet will settle down. And it may be fine. It should be fine. It was fine in last time as well. Coronavirus is a big challenge, but it's a momentary disturbance. In the, if you look at what was the answer? What was the question? What were you saying? I couldn't hear. The last person who was.
Hidden hunger could be a greatest challenge in today's time. Hidden hunger.
Hidden hunger. Hidden hunger, or what you're saying?
Yes, sir, hidden hunger.
What is hidden hunger?
So hidden hunger means we are getting our food. The food is not an issue, but the nutrients is definitely the issue, that our food is deficient of the necessary nutrients that we are supposed to get in order to live a healthy and meaningful life.
Is a challenge. Yeah, that I agree. That is a challenge. The quality of food, because it's more organic food is not possible anymore. It's mostly genetically modified. We don't know how it is working with our body. That may be linked with scientific development also. So that is a challenge. But if you really see a broad problem which is covering and facing the humanity, we are again seeing a same kind of peak. Okay, just like Haber was seeing this population explosion, what we are seeing today is the peak oil. Okay, and that is called the Hubbard peak, because Hubbard predicted this peak. He said oil is going to peak in about 2020. You can see right there, you are here. And then there will be less of the fossil fuels. And you have to find some resources. You see there are wars happening around in the universe, on Earth, like in Middle East. Huge wars are happening. And you see all these countries, what are they after to? Like since 2001, we had the Iraq war, and later on, all of this is behind securing energy resources, because oil is depleting and oil is gold. So this peak is telling that we need to do something about it. And people have started in this century at least thinking about alternative energy, renewable sources, sustainable processes through which you can feed the planet, you can provide the energy needs. Okay, so you are seeing a peak. You need to do something today to solve this problem. Just like Haber was saying that I can provide the bread from air. Hawa se roti banaunga. Kaise? I will fix nitrogen. That will make ammonia, and ammonia will be the fertilizer that's going to increase the food production on the planet. Of course, I understand the nutrients is an issue, but at least people are getting something to eat. India was an importer of wheat grains in 1947. Today it is an exporter. Despite that, we have 4 times more population since independence. Okay, we are still able to feed people, and getting some food is nice. Same way you are thinking about how are you going to sustain the energy requirements of per capita on this planet. 7 billion people, if everybody wants to maintain a life which is the life of a US citizen with the same energy requirements, you might need 60 planets. Okay, so how do you sustain this whole planet, the energy requirements? We see all of us need more and more energy. You need laptops, you have iPads, you have cell phones. Things are adding up and you need some power for all of this. So, and you need to travel, you travel more. All of these things are important. So this is the challenge which we are facing today. What is the solution? Can anybody tell me the solution? Anybody can respond with the solution. What will be the solution? Just like Haber, can you think about a reaction which can solve this whole problem? Like Haber
The
thought about
hydrogen fuel, hydrogen plus oxygen.
great, Khalid. That's the way we are. But how to fix this? I'll explain you the most sustainable. Okay, let's go back 100 years ago. What Haber discovered, Haber didn't knew this, but he was able to discover catalyst materials which has cavities. You can see here the cavities. So nitrogen is this N2 molecule will come on this top of this surface, and in these cavities it is trapped. So it's able to dissociate the nitrogen triple bond and capture that nitrogen inside that cavity. Okay. Then the hydrogen job was simple. Once nitrogen bond is dissociated, hydrogen was able to, it should be hydrogen, I just wrote wrong. It should be hydrogen plus nitrogen. So hydrogen was able to hydrogenate this nitrogen to make ammonia. Okay. So he was able to discover this catalyst. But this is the scientist, Professor Erd in Germany. He explained how this material is working 100 years later. So 1920 something, Haber discovered. Gerhard Erd explained how it actually happens, and ammonia synthesis is amazing because how you can use something inert like nitrogen and make something out of it. Nitrogen usually doesn't react because of these catalyst materials and these cavities where you can trap the nitrogen atom and dissociate or break this nitrogen triple bond. And Erd was able to explain it. He got the Nobel Prize in 2007. So you can see it's a millennium problem because somebody discovered it and somebody explained it over the span of 100 years. This problem is still relevant today. I see very good papers, very good research work. Even today, how you are going to do this at ambient pressure and temperature, how are you going to do it? It still requires high pressure. So how are you going to work with the economics? The pleasant thing today in the online talks is that you can enjoy your tea and talk. Okay, so please enjoy your tea if you are having tea or lunch or anything, and we can think about science. Okay. If I talk about this problem, this essentially is a catalyst design problem. And we talk about as catalyst. And anybody can tell me what catalyst is? Can anybody tell me? Among you, you must be knowing the definition of a catalyst material. What does a catalyst do?
So fast the rate of lowers activation energy.
Lowers the activation energy.
Great. All of you are familiar with catalyst. Catalyst, the reaction is happening, but it requires an activation energy. It needs a barrier. Catalyst pulls the barrier down, makes the reaction easy. So you need more energy for a reaction to happen, but once you have a catalyst material, it brings it down. Same thing what he did. These cavities at the molecular level was dissociating the nitrogen. You don't need that much energy to break the nitrogen bond, and this reaction can happen. Okay, so barrier is lower. So that's what exactly lies in the vicinity. Okay, this was 100 years ago. Haber didn't know he was doing something like this, but he did it, and this guy was able to explain it. Okay, Now, if I ask you, what is the solution today? Because you are seeing a similar kind of peak. You want to provide a sustainable solution for the entire planet for the next 100 years, okay, or a complete foolproof solution. What is the solution? There are so many things people talk about, like you said, hydrogen energy, solar cell, batteries. What is the final solution? Nuclear power, coal, thermoelectric, anything. All of these different types of energies you learn in a general knowledge book. What is the final solution? What are you going to do? That is where we need to figure out. And I think the answer to this lies in, you take your cup of tea, like I am handling, go outside. Look at, this is raining outside in Delhi, and you go outside and look at nature. Nature, how nature is doing this thing. Nature, before we arrived, and since we have arrived on the planet, like I don't know how many years ago, when Adam came or the first man arrived on Earth, nature is doing it before that, even for thousands of years before that, and it's still doing it. How it is doing, a plant, a tree, it's capturing, and this is the solution. I'm giving you the answer here, right here. Nature is taking sunlight, it's also taking water, there are some minerals, and it's producing all these sustainable sources of energy. All of these are energy sources: wood, food, crop, even waste. You think it is waste? It's not waste, it's a rich source of energy. Nature has made this sustainable. You can use this waste, you can use the eatable food crops as well, food, and also, as well as wood, like cellulosic biomass. All of these are rich, and nature has been sustaining all requirements, energy requirements for all organisms for thousands of years. Now, nature cannot help us in charging our batteries or directly plugging into a tree and your computers. You can't do this with nature because nature hasn't promised us, but our requirement is increasing. So we have to think how we can devise systems like nature which can use sunlight and water and do a same job. So I will replace the tree with my device. What do you think is the solution if I take inspiration from nature? Can anybody respond?
So there's no realistic path to a zero green emission thinking that we can abandon the fuels completely.
Yeah, so you said there is no realistic path.
Nature, we can think about a zero carbon.
So you are
where
not.
we remove the carbon.
We need optimism here because you are in 11th and 12th. You are the future scientists. You are NTSE scholars. You are the future scientists. So you have to tell me with optimism, what is the future, man? You have to solve the problem. Just like Haber said, forget about it. I'm going to give you the bread from here. I'm going to break the nitrogen.
Wanted to emphasize that we will still be producing some emissions, but we have to find ways to remove the carbon we emit. On focusing on removing the carbon as well, not only not producing.
I am saying one solution which will not produce any carbon, which is the most sustainable solution. People will be easy to use it. There should not be any problem at all. In the most sustainable way, just like nature is doing. Nature is using sunlight and chlorophylls are capturing this sunlight. Then there is some water, some nutrients, and it produces ATP, ATP, all this energy, electron transfer cycle. All of this is done in the most efficient way. And no carbon. Nature overall carbon balance is fine. For the planet never faced any climate change issues or global warming for thousands of years. Everything was in balance. So what you are going to do? Anshveer Singh Bhatia, yeah.
Sir, if we can do something where the carbon product can be obtained as a byproduct which can be used in some or the other way, and our main aim is achieved, that it is not also creating the pollution, it is being used in some or the other way.
Okay, great. But I'll give you a hint. Hint is, just like Haber thought in 1920, it's going to be one simple reaction, N2 plus hydrogen making ammonia. I think in 2020 you have to just think about one reaction.
H2 plus O2 changes to H2O.
Who said that? Kalika. Yeah, Kalika. Yes. Really awesome. Awesome answer. Thank you. This is the answer actually. Like Kalika said, and I have the answer. but you have to think about the design part. The design is the nature has very efficient design in place. How nature is doing it. Like when Haber was discovering this catalyst, the design, look at this is just two-dimensional design. He thought about these cavities. This guy explained it, but these cavities are just two-dimensional, just to trap this nitrogen atom, give you the ammonia. Okay, very simple molecules. Nature, when you see the chlorophylls or enzymes, they have very three-dimensional cavities where a molecule is trapped, like ATP makes ADP. Very big molecules, very high specificity, very high level of engineering in place. So you can see what nature is doing, what human beings are doing. Okay, there is a long way to go, because how you design these cavities, these molecular cavities at the molecular level, which can trap a molecule, give you the product. Okay, so this is where you have to go. Okay, and the solution, for example, what we are thinking today, how I'm going to transform electricity, make it sustainable, again is a catalyst design problem. And I'll tell you again, what is the answer? There is sunlight, there is water. What I'm going to replace in front of tree, what kind of device it's going to be, and you have given me the answer. This is the final answer. Okay, can you all read this? Kalika, you said the reaction. Now you explain me what is the solution. What is the solution you are seeing?
So we can combine H2 and O2 and it releases a lot of energy, and there's no pollution as only H2O is produced, which can again be used as its water. And the energy which is released can be used to produce electricity and run various homes.
This is great. Okay, this is really awesome. I teach a class, but I have not seen such a smart students. Okay, IIT so far. IIT students are still behind than you guys. Okay, this is very, very inspiring. Okay, and I thought a lot whether it's going to be nuclear. Not everybody is comfortable with nuclear power plants. Some countries are not even allowed to use it. Even in India, people will say, "Oh, not in my backyard." That's called not in my backyard. Even in the US, so nuclear is, maybe it produces a lot of energy, it's clean, but not as the final answer. You don't want nuclear power plants. As someone was saying, carbon is always an issue. You want something where it's not messy, it's not going to be carbon, so not biomass. What is the final answer? And final answer is the same. I'm putting it right here, sunlight and water. You want to break water using sunlight. Listen to me very, very carefully. You don't want to add electricity there, because that's another cost. Producing electricity will produce carbon dioxide or something else. You don't want to do that. Okay, you want to just use photons to break water. That's an amazing problem, because you can add electricity, do electrons. Stop. Subhajyoti. He is my student. Some of my PhD students. So I'm trying to. Subhajyoti, you need to switch it off. Okay, you switched off. Okay. So you want to do this. You want to break water, produce hydrogen as a fuel by using photons. Now, Sarah's group at MIT is leading this efforts. What do you need for this? To break water using photons. What do you need? Can anybody tell me what do you need? What do you need here? Anyone can respond. What do you need?
Solar cell.
Not solar cell or this.
The electricity.
Electricity, no electricity.
Anode and cathode.
Don't that. Photons and water. What else do you need in the beaker? In that beaker, what else do you need? Who said that? If you just show water and sunlight, it's not going to produce hydrogen because the barrier is so high. But if you add a smart catalyst material, just like Haber thought about a smart catalyst material which can fix air to produce bread, same way you can think about a catalyst material today. Hopefully you discover it, which you put inside the water and it's going to break it because it's going to reduce the barrier. You just use sunlight. That's the most sustainable way. Sun is the source of energy. Sun is our God, one way or the other way you think, okay? Sun is producing, sustaining this planet. You just use sunlight, water is there in the oceans, you just use water, break it. But you need photocatalyst materials, okay? You don't want to add electricity because here you want to add minimum energy in the most sustainable way to produce fuels. Now once you are able to do it, Norsera's group at MIT is leading that effort. I encourage you, watch some videos, see some things, then you will be able to see that you can also do it, okay? So you produce the hydrogen. Now hydrogen is a fuel. Now you don't need petroleum, or you don't need CNG, natural gas, you don't need coal, nothing, pure hydrogen. Now hydrogen is itself is not an easy fuel to handle because it's a light gas. So of course there are problems that you need to liquefy it. That's a challenge. How are you going to put it on your car? That's a challenge. All of these hydrogen pathways, all of these are still a problem. But let's suppose you solve all of this. Okay. You are able to liquefy it, you are able to put it on your car, you can put a hydrogen cylinder at your home and recharge, run your all electricity demands at home. There is our charging stations with hydrogen pathway, anybody can fill in their tanks with hydrogen. All of this is, let's suppose all of this is mechanical problem are solved. But chemically I'm talking about, or philosophically, once hydrogen is there, how are you going to, because it's a chemical, it's not an energy. Okay, it's just a fuel. How are you going to use hydrogen to produce electricity, the electric power, or the energy demands, what you need? What are you going to do? Anybody can respond. The answer is right there on the slide. What are you doing? What? Somebody said something. What are you going to do once you have hydrogen? Not combustion. That's the inefficient way. I'm showing you a device here that converts chemical energy directly to electrical energy. That's called a fuel cell. It's called a fuel cell. It uses hydrogen, and the principle is you combine it with oxygen, produce water. Okay, on the other side of the electrode. Protons are transferred inside the electrolyte, and in this whole cycle you generate electrons, and that electrons are the source of your electrical energy. So it converts chemical energy to the electrical energy. Okay, here what do you need? In this fuel cell, what kind of materials do you need? Can anybody respond?
Anode and cathode.
So we need photovoltaics.
Not photo. Here it's not photo. Be very clear. This is fuel cell. What kind of material in the electrode? These three components are there: electrode, anode, cathode, and electrolyte. What kind of material you need?
Some inert material.
Not inert materials. Anybody can respond. See, the reaction is flipped here. Here, when you are breaking water, you are producing hydrogen, you are storing hydrogen. You need some catalyst materials which can use just photons, and that's why they are called photocatalysts, because they use photons to act, reduce the activation barrier, and you can produce hydrogen. Here also you need catalyst materials. If you really look at it, there is a reaction. Reaction is just the reverse, hydrogen plus oxygen combining and making water. So you need some kind of catalyst material which can do this job easily. You are combining hydrogen with oxygen and generating back electrons. Okay. Here you need the catalyst materials when you are doing the photocatalyst and producing hydrogen. Here you need the catalyst material which takes minimum energy to produce hydrogen, because if you add electricity or more energy, that catalyst is useless. Okay. Here the problem is reverse. When you are using hydrogen produce electricity, you need a catalyst materials which produces more electrons. It produces more energy, okay, from hydrogen. It efficiently converts thermodynamically. It can efficiently convert the fuel hydrogen into electricity. Okay, this is the key design. If you really see the problem is the most sustainable solution. No nuclear, no war, no oil, no biomass, no. The problem which is facing this planet today is you want to break water, produce hydrogen and oxygen. You want to combine hydrogen with oxygen, produce back water. On one side, you want to give minimum energy. On the other side, you want to extract more energy. Okay, both sides you require efficient catalyst materials. Okay, just like Haber thought of new catalyst materials, you need to talk about new catalyst materials. Okay, on the one side, it's called photocatalyst because it uses photons. On the other side, you need electrocatalyst materials because it is driving electrons. Okay, that's scientific definitions, but eventually it's all about catalysis. It's essentially is a catalyst